All right. So we can get going here so you guys can have whatever time you have left to work. For the test, I did correct everybody's test that took it before I started teaching today, so I know there were a couple of people that were finishing up yet. Once everybody's done taking the test, then I'll open it up so you guys can go over to check out your answers and your score and things like that. But otherwise, overall, it was okay. As long as you guys remember, you can use your notes, you can use your book, you can use whatever resource you guys have, just not each other. That's kind of why I try to set up these notes for you each day, so that you guys have some things written down that match up with the questions you're going to get. So today, if you look in the folder, it looks like there's a lot. There's 4 separate folders. But it's actually not as bad as it appears, just because of the material we have. Most of it is pretty quick. I also did try to set it up because they canceled school Friday. We didn't have an extra day that we could give. So what I did was I took Friday's work and kind of put it on Thursday. And so this week we've had a handful of work that I've kind of allocated over the days so that tomorrow wasn't too much of a overburden. We'll actually be done with chapter 4 tomorrow, and the review is part of Thursday's work. So let's start with 4.3 though. So writing an equation from a table. First thing I would do is I want you guys to understand and realize that every one of these tables is going to be set up with one of the 4 operations. So multiply, divide, add, and subtract. Now, this is the first thing you should check for. Okay? So you're going to check to see if the numbers somehow, if I'm looking at the 4 and the 1. Okay? If it's multiplication, if I multiply 4 by something to get an answer of 1, then I should be able to go to the number next to it and do the same thing. So then that's kind of how it works, and I think you guys probably somewhat know that. So looking at these numbers, I guess the first thing that stands out to me is they're all, in a row. 1, 2, 3, 4, -2, -1, 0, 1. So that says to me it's probably something to do with addition or subtraction. So if I'm looking at them, it looks like the bottom number is 3 smaller each time. And if the negatives kind of throw you off, start with the easier numbers like the 3 and the 4. But since I saw the exact same pattern on each one of these, then this would be y equals the x number minus 3. So basically the bottom number is equal to the top number minus 3. And they definitely get more difficult if you have 2 things happening. So 2 times x minus 1. So you've got 2 operations. So I don't necessarily have great advice for you, other than the majority of it is to just try to look for the patterns. So I have one down here below that I'd like you guys to try. This pink one. Why don't you guys see if you can figure out that equation from the numbers written there. Okay, so before I call on somebody, I guess what I kind of recognize is, like the pattern, these are going up by 1s, but these definitely aren't. These go down by 3, down by 3, down by 3. So they have a different pattern between them. Jacob, did you figure out how you can go from the top number to the bottom number each time? Okay, what do we do? Perfect. So if you multiply by -3 each time. Okay, so the top number times -3. So then my equation would be y equals -3 times the top number. Nice job. I mean, that's it for the first part of 4.3. Second part of 4.3, I mean, it feels totally different, you know. And honestly, that happens sometimes. Our end goal is we're trying to take all these little things we learn and then put them together into like these larger problems. So this one's about independent and dependent variables. Okay? And, I mean, like, I wanted to write down a definition for you, but when I started writing it, it just seemed worthless because the definitions are, like, based on the words. Well, the independent variable is going to be the variable that changes, or what. Yeah, I mean, I was going to say dependent. This is what most of you would think about as the x. And that's because we usually put a number in place of x, right? So the independent variable is the one that you generally work with. The dependent variable is the answer that depends on whatever you put in place of the independent variable. So it depends on the x. So this is what we usually think about as the y. Because every one of our equations is usually set up y equals something x plus something. So our y answer comes from whatever depends on happens to x. Jacob, you got a question? Oh, all right, no problem. Oh, yeah, okay. If you had a question, that works. All right, so here's kind of what we're supposed to do. Is we're supposed to look at situations and then figure out, which one depends on the other one. So it says the faster Ron walks, the quicker he gets home. Okay, so here's my two situations. I've got Ron's speed and the time it takes him to get home. So if I'm looking at this appears to me that speed is going to be independent because if you change the speed, faster speed gets home quicker. Slower speed gets home longer. So basically, if you're changing your speed, well, then it affects your time. So your time to get home depends on how quick you're walking. So speed would be independent, time would be dependent. Second one, in the winter, you use more electricity. What? I wrote that terrible. Oh, in the wintertime, you use more electricity the colder it gets outside. And, I mean, that's only if you're using electric heat. So, our job is to try to figure out which one's which. So, we've got the electricity and the temperature. Now here's one that definitely only works one way no matter what, right? We can't change. No, I shouldn't say that. Cullen. Cullen, do you think you could help me on this one? Which one affects the other one? Perfect. Perfect. Wait, aren't you like in a different country or something? Now that's dedication. I like it. Where'd you say you went? Okay. Oh, Nova Scotia. I was thinking you said New Zealand. Okay, Nova Scotia's a lot closer. Okay. But yeah, what you said was perfect. The temperature outside is going to be the independent variable in this situation because the temperature affects the amount of electricity you use. Independent. And this could have been natural gas, whatever, however you heat up your house. So here's the situation I wrote for you guys to try. See if you can figure out which one is independent, which one is dependent. Gracie. And I don't know if you're still writing this down or what. Do you have a thought as to which one is independent, which one is dependent? Okay. And is there anything in the words here that kind of stuck out to you to tell you which one is which? Perfect. So in the wording of this sentence, it pretty much directly tells you that the cost is based on its weight. So the weight affects the cost. Okay, good. I mean, like, these are probably annoying for notes just because you had to write down the sentence type thing, but they're decently quick problems. All right, 4-3. Also more random things here. Excuse me. It says for f of x equals 5x, find f of x when x equals 6 and x equals 7.5. I know you've done a bunch of these in the past. I wanted to include this in your notes because the fact that there is two x values here was confusing for a lot of people in the homework. So I wanted to put this one in just to kind of include that. So what you're going to do is you're given an equation to use. And we're going to kind of just make like a tiny table. So the x values were asked to do two different ones, 6 and 7.5. So it's kind of like two separate problems. So if x is 6, f of x would be 5 times 6, or 30. If x is 7.5, f of x would be 5 times 7.5, because it's 5 times x. 5 times 7.5, what is that, 35 and 2.5? 37.5, I'm pretty sure. And so these would be your two answers. It's not that the actual problem here was difficult, it was more the setup of the problem is what some people had confusion with. So here, I put one here that you can do on your own. I tried to make it easy enough so that you could do the numbers in your head. Why don't you guys try to find these two answers relatively quickly? Sophie. maybe I went too quick. Were you able to finish this already? Okay, no problem. It's hard to tell when I can't look at every right. So why don't you just kind of finish up, and then when you're done, maybe try to explain to me how to set it up. Okay, good. Okay. Yep. Yep. So what'd you get? What's half of 8? What's half of 8? Okay, and then minus 1. Yep. Oh, it's negative 10. Okay. Whenever you got negative from. Yes, you are 100% correct. You're better. Your eyes work better than mine. No, good. And that's pretty much it. The annoying thing is sometimes if the numbers aren't that great, then you kind of have to use a calculator. Okay, 4.4. Like, we're already done with 4.3. That was, I could have gone through it probably quicker than I did. It probably took you longer to write some of the stuff than to do it. Now, 4.4 is a little bit slower, so that's why I wanted to kind of get here quicker. So it's all about graphing. And I know some people are good at graphing and some have troubles with it. So I wanted to definitely go over, just go over how to do it. And if you're a person that's really good with this, you'll probably that I'm going to go slower. So the first style question is graphing a function given a domain. Now what this means is we're told what numbers to use only. Okay? So we're basically being told the numbers to put in a table. So we are told -4, -2, 0, and 2 are the numbers that I want in for x's, because the x's were the domain. Well, the y's are what we're trying to figure out. So what we have to do is we have to take this equation and change it around so that it says y equals. And we kind of purposely want to do that because we have this set up as x is the independent variable, y is the dependent. So we want to change it around so it says y equals to make it. That's basically so it's the answer. That's kind of what dependent means. And I'll tell you what, since you could probably hear whether it's annoying or not, by far the one that's most excited about me getting a normal computer desk now instead of my kitchen table is my old cat. Because she can't jump up to my kitchen table. But she can make it up on the computer desk, so she's pumped. She is actually older than you guys. She is 17 and a half. So she is stubborn and annoying at times. Okay, so if we were trying to solve for y, we want to kind of get rid of this x. And then it says 2y equals 6 plus x. Well, I need a regular y, so I want to divide everything by 2. And I can do this two ways. I can divide each of them by 2, or I can divide the whole side by 2. Both ways are correct. It's kind of just up to you, whichever one you would prefer to do. So I'm just going to divide the whole side by 2. I don't know. I feel like it might be easier. We'll find out. So my first one, if x is -4, I'm going to put -4 in place of x. And then divide by 2. So 6 plus -4 is 2. divided by 2 is 1. And then I'm going to do negative 2. 6 plus negative 2 divided by 2. So that's 4. Divided by 2 is 2. 6 plus 0 divided by 2 is 6 divided by 2 is 3. And I feel like the pattern here says that's going to be 4. 6 plus 2 divided by 2 is 8 divided by 2 is 4. Okay, I did a lot of work here so far. And it feels like I should be done. But we actually have more to do. Who should I call on? AJ. AJ, when I say I have more to do, what do I have to do? Yeah. Okay. I'm not sure the best way to do this if you're going to type the answers. Out of that table of numbers, how do I graph that table of numbers? Do you know that one? How about this? Let's go with Callie. Callie, do you know how to read this table and put that on the graph? Perfect. Perfect. This is basically a point. Yeah, excellent. So negative 2, 2, 0, 3. Nicely done. Okay, so those are going to be my 4 points that I'm going to graph. So negative 4, 1 would be 4 left, down 1, negative 2, 2. Wait, is that right? Oh my God. You guys got to yell at me. I went to negative 4, negative 1. Negative 4, 1 is up here. There we go. You guys got to do a better job of telling your teacher when he's, you know, I was gonna say when I was being dumb, but that's not being dumb. They're just mistakes. So negative 2, 2. 0, 3. 2, 4. Do you guys know how I knew I screwed up? Because this is good for you guys to do too. How did I know I screwed up? Olivia, how about you? Do you recognize how I knew I was wrong when I put the point down here? I mean, yeah, you're definitely correct saying that too. I don't know if you saw what AJ typed in. I basically knew it was wrong because my information didn't go in a row. Like if I drew the point down here, it didn't make a line with the rest of the points. So whatever kind of graph we have, you're generally going to be able to see a pattern with the points. They don't all actually have to be a straight line. So, because we're going to have an example coming up that's not a straight line. But you'll at least see a pattern with the points. So you'll kind of know if you made a mistake because something will seem off. But yes, Olivia, what you said was definitely correct too. Okay, so 4.4 example 2 is actually exactly the same as what we just did, except, Caleb, what's the difference between these problems and the one we just did? All right, fairly straightforward answer. So if I you do know now? Oh, okay, go for it. Okay, well Actually, that's true too. How do I hear music? Oh, are you at home? Oh, okay. I thought the music was being played in the classroom. Yeah, no, you were correct where this one is actually already solved for y. So that definitely is true. The main difference is that you're not given numbers to use. Like if I go up to this first example, we were told what numbers to use, and so we were told what numbers to make the table with. And it's definitely not a big difference, but I know in the past years, this is where a lot of people get thrown off. Like you feel like the problem is too wide open. Like I know some people just like being told what to do, right? So what we're going to do is we're just going to make our own table. And we're just going to choose our own numbers for x. And you know what? I'm pretty horrible at drawing lines. Let's be honest about that. Let's cheat. I like this. Whatever. Okay. Can I drag it? I can't drag it. Oh, what? Weird. Who hasn't been called on yet? Christian. Christian hasn't been called on yet. Are you ready? Your question. Your question, of course. What number should I pick? Are you just copying the numbers that were in the previous one? Okay. I can only halfway hear you because your microphone's going weird. But that's all right. Here's what I'd recommend. Let's pick the easiest numbers we can think of. -1, 0, 1. And let's use the easiest numbers we can think of. And if we go to graph it and we can see a pattern, then we'll just stop there. If we can't totally figure out the pattern, then we'll do some more numbers to see how the pattern goes. Okay, good. I think you were on that same path, Christian. I could only halfway hear. Let's plug in 0 first. That's by far the easiest. 2 times 0 plus 1 is 0 plus 1 is 1. Then I'll do 1. 2 times 1 plus 1. 2 plus 1 is 3. Perfect. Yep. No, perfect. Okay. Okay, we've got 3 points. Let's graph them. And if they make a nice pattern, we'll be done. If they don't make a nice pattern, well, then we go make some more. 1, 2, 3. So -1, -1. Whoops. -1, -1. 0, 1, 1, 3. All right, Christian, does that look like it makes a decent pattern, or? I agree. That definitely looks like it's some sort of a line. So I'll quit there. And basically we kind of know what the graph looks like. If you want, you can connect them. You don't have to. But yeah, good. Okay, let's go to Logan. Logan's just going to tell me what to do beginning to end on B. Because Logan is a pro at this. Okay. Okay, what next? That's your job. But yes, you're right. Good choice. Okay, so now this one's squared. So we're going to take this number and square it. 1, 0, 1. Negative 1, 1. Okay, Logan, we've run into a slight issue. What is the issue? That's definitely not a line. Yeah, you're right. So, one of two things happened. We either did it wrong, or we've just got a different pattern. So, we're going to pick a couple more numbers. I'll just pick the next two easiest, and we'll see if it continues this weird pattern, or what. Now, if the rest of the points follow a line, but one point is off, then I'd go and check that one number. So negative 2 times negative 2 is positive 4. 2 times 2 is positive 4. And, I'm off my chart. So, this actually does look like it has a pattern on its own, different than the first one. And this one actually makes a curved U shape. So it's a parabola. So that's kind of the goal when we graph. You did very good there, Logan. It's kind of our goal, is you figure out if there's a pattern there, or maybe you did something wrong, and then you just kind of put some more numbers to see if the pattern still goes. Straight lines are the easiest because they're just easy to visualize. Did anybody know that this one was not going to be a straight line right away? I bet a couple people did. I don't even know who to call on or ask. It was the square. So over here, we had a regular x. This one had an x squared. So you will recognize some of those changes as we learn more chapters and things. But the squared is what makes it not a straight line. Okay, good. We're getting there. Example 3, finding values from graphs. I will give you guys a couple minutes. Why don't you guys try to draw this first? The toughest part would be to draw this graph, kind of like I did. Caden, did you have a quick question? Okay. Did you join an accident, Caden? All right. Oh. Got it. Okay. So if you want to wait about 15 minutes, if you want to come back in about 15 minutes, then I'll be done teaching algebra, and then I can help you with your question. All right, so we've called in everybody in here. I need somebody who's really good. Is there somebody who's going to volunteer for this? Oh, all right, Logan. Do you know how to do this one? Okay. I was just going to kind of give you zero guidance and see how it went, or if you want some help or whatever. Given the graph, find the value of f of x when x equals 4. How do we do that? Where is x equals 4? Let's go with that. Where's x equals 4? Okay. It's 4 to the right. So if I draw a dotted line 4 to the right, the value of f of x is going to be the height of f of x on that dotted line. So what would you answer? I mean, this is basically just estimating and guessing. I'd go with that as well. I would approximate it to be 2. And that would be our answer. These questions are great as long as you know what to look for. If you're not sure what to do, obviously they're difficult. But if you know what you're supposed to do, there's almost no work involved. So let me put this one up. And it's all right if you don't even want to write it down. You know, like, if you understand these questions and you didn't want to write it down, that's fine. You can just answer it from here. How about Sophie? Do you think you can help me with this one? All right. That's all we ask for. Correct, correct. So, yeah, I mean, like, obviously because my pictures aren't great, it's hard to tell the exact answer. So guessing is totally good. On the questions you guys are going to get, there's like a grid, so it's really easy to tell. I'll just make my dots super big so that it looks like it's on -2. Yeah, I think you said -1, but it's kind of like in between them. So we'll go with that. -1 or -2. Good. Okay, last question, and then we're actually going to be done for the day. So, it is exactly what we have been doing, but it's a word problem. So it says the function, let's see if I can zoom out a little bit. Whoa, I can. There, now I can fit the whole problem. The function y equals 2.5x describes how many millimeters the sea level rises over how many years. So x refers to the number of years, and the answer is the millimeters the sea level has risen, so y. Use the graph to estimate how many millimeters the sea will rise in 3.5 years. So, you know, downside to word problems that I'm sure you guys are in the same boat as what I always was as a student. I hate writing these down. Like, I'm always blown away at, like, writers from forever ago. Like, they would literally write whole books. And I get annoyed at writing, like, 2 sentences. So, Caleb, do you think you could help tell me what I should do? What? Oh, you're writing it down. Oh, okay, go for it. I'll wait. I'll take a drink. Now, if you're trying to draw the graph, there's two easy spots to go from to make a nice line. You have 0, 0, and then you have 4, 10, and then 2, 5. Those are the nice numbers where the graph would cross nicely at. All right. You have any thoughts as what we should do? After all that, nope. So it says, how many millimeters will the sea rise in 3.5 years? Say it again. Our answer is going to be y. So the years is x's. Okay, so where would I look for 3.5 years on the x-axis? Yeah. I guess I meant which one is the x-axis, up and down or left or right. That's what I should have asked. Yeah, you're right. 3.5 is between 3 and 4. So we would basically look directly in between 3 and 4. And then just make a good guess as to what this height is. Yeah, I mean, I have no idea either, right? 6, 7, these will go by ones. Yeah, let's go with that. So, here's how we'll answer this. 8-ish, 9-ish. That's good lingo for about. Now, if we wanted to know exactly what it was, we could do 2.5 times 3.5. But the whole point of this question is just estimating. So 8-ish, 9-ish. I'd take either one of those answers. They're both good. So whenever it says estimate, then you guys have a little bit of freedom as to how you answer it. Okay, good. This is pretty much it. I mean, it's 2 sections, so it's actually a lot of folders in your work, but that doesn't necessarily mean it's a lot of actual work and a lot of actual time. So most of you should be able to finish before you leave class today if you're in the classroom. Yes, AJ. Where do you go, AJ? Are you going to a different room? Or are you at home, like, just want to know if you can get off? Oh. Yeah, we're done now. So you definitely... I will stay on till... Time do we get done again? 1:35? I'll stay on till 1:35 if you guys want help with anything. Otherwise, I appreciate you helping out. You guys did a great job answering. Yeah. Oh, yeah. I sent you one back. Yep. No, thanks for letting me know.